Are rolling. All right. We are going to learn how to graph sine and cosine functions today. We have already done this, although you may not know it yet. You may not know that we graph a sine and cosine function. But once we do, I'm going to ask you if you recognize it. So, we are skipping the first page, though. We are going to be breaking out our unit circle to help us with this page. Okay? All right. Now, we're going to fill in this table right now. And we're going to figure out what the sine of 0 degrees is. Who can tell me what the sine of 0 degrees is? 0. Thank you. You guys are listening. Oh my goodness. 0. Okay. All right. Sine of 30 degrees.
1,000. I'll do it on my calculator.
Ah! No.
1/2.
1/2. Now we're going to put it in decimal form. I'm not a fan of decimals, but we're going to do decimal form. All right. Third value. What's the sine of 45 degrees? Square root of 2 over 2. Now let's convert that to decimal form. Where's your calculator? Huh? No, calculator. Like real calculator. Always bring your real calculator to class, not your cell phone calculator, your real calculator. So, what is square root of 2 over 2 in decimal form? 0.71. We'll just call it 0.7. Sine of 60 is square root of 3 over 2. Put it in decimal form, and what do I get? 0.866. We'll call it 0.9. And then the sine of 90 is 1. And then, what should happen after 90? It went up. Now it's going to start going down because we started here. Now we're here, and now we're going back down. So my y's are going down. So this is going to be 0.9. This is going to be 0.7. This is going to be 0.5. And this is going to be 0. Now we're here, right?
Negative.
Now we start going up, but in the negative direction, right? So now it's negative 0.5 and negative 0.7 and negative 0.9 and negative 1. Now we're down here, right? Now we're going to start going back up closer to 0 from negative 1. So it's negative 0.9, negative 0.7, negative 0.5, and 0. Do you see that all we need is that first quadrant of values? And then I just repeat. There's a pattern there, right? Just the first quadrant. That's all you should need to remember. So now, we're going to graph this guy. Scroll down a little bit more. Okay. So when theta equals 0, my sine equals 0. So where do I put a dot? At 0, right? But 0 is not a point. 0 is a number. 0, 0. Thank you, Jeff. At the origin. At the origin. Now, when theta equals 30 degrees, I don't like how they did the graph here. You know why I don't like it? No. So how do I split 90 up to get 30? I divide by 3, right? And look how many squares there are. There's 2. So I'm going to have to go in between a little bit. So when theta is 30, what's this line right here? 45. Thank you, Nick. So 30 is a little bit on this side of 45. And when theta equals 30 degrees, my sine is 0.5. Let's call that 0.5, which means this is what? 1. Okay. When sine is 45, right here, right? Then I'm at 0.7, which is a little bit higher. Ooh, a little bit higher than that even. Let's just do that, and then do that. And then, at 60 degrees is at 0.9. So that's like right there. No. Come on. 0.9. How do I calibrate this again? I need to calibrate, guys. I'm better with my finger. There we go. Now let's undo that and put, there we go. Now, at 90 degrees, what's my value? So I'm right there, right? And then, right, I go back down, right? I start going back down. So at 120 degrees, I'm down a little bit. At 135, which is halfway between 90 and 180, I'm down a little bit more. At 150, I'm at a little bit more. And at 180, I'm back at 0. You with me so far? All right. And then I'm back to doing it in the negative side. There were... So packet is right on the corner there, Anthony. So now, 30 degrees past 180, I'm at negative 0.5. So, right, not quite halfway, I'm at negative 0.5, right there. Yes? I'm good? We tell them stop. At 225, halfway, I'm at 0.7, right about there. At 240, I'm at negative 0.9. So 240, right about there, negative 0.9. And at 270, I'm at negative 1. And then I go back up again, right? Boom. 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 Now, I'm going to do this. I'm going to do the line in blue so you can see the dots and you can see my curve. We go right here. God bless America. I'm bad at this. So, this is the part where I ask you, what does this look like?
Parabola.
We did this earlier in the unit. What did we do this for?
Ferris wheel.
The Ferris wheel. We did this for the Ferris wheel, right? How high was it? Depending on how far it rotated, right? The Ferris wheel height was a sine curve. The next one asks us to graph the interval of the sine function above, so it's graphed on the interval from negative 180 to 270. Now let me ask you, negative 180 is right here, And 270 is all, not 270, 720. Sorry, guys. 720. So negative 180 is right here, and negative 720 is over here. Let's do the from 3, we've already done from 0 to 360. What's it going to do from 360 to 720? What, Caleb, say it in words. Is it going to look any different than the first time we did it? It's going to be exactly the same, right? So it's going to go up and then up again. Forgive my terrible artwork, but we know that this part right here, looks exactly like this part here. Riddle me this, Batman. What does it look like in this part? What does it look like on the negative side of 0? It's going to be the same. So if I was going backwards, right? I'm going down here, right? I'm going down, down, down. And I'm going to keep going down here, right? And then I am back up to 0 right there at 180. Do we see that? Ava? Okay. This is the graph from negative 180 to 720. So, for the interval of negative 180 to 720, describe the values of theta at which tell me what values of theta there are relative maximum and minimums. Right. What is it? Andrew's on it. But let me see if somebody can unpack what it means to be a relative maximum and minimum. If I'm going up and then down, the relative maximum's at the peak, right? Yep. But I'm not really. I'm asking for what values of theta, so I'm really looking for that guy, right? Because that's where it's at a maximum. Okay. So for maximum, so at maximums I'm at 90 and what's that? Are you talking about this right here, Sophie? That's the plural for maximum. It's Latin. So they have different rules for plural. And then 450, right? And then for minimums, minima, what values of theta for the minima? What do you think, Nick? What do you think, Nick? Minima, what values? 0 is a minimum? Right here? What's the value of theta there? Negative 90. And what other minima are there? There's 270 degrees. And there is 630. Yeah, go ahead, Andrew. And can we figure out what intervals this curve is increasing? From the minimum to the maximum, it's increasing, right? How about when it's decreasing? From the maximum to the minimum, right? And then, what values of theta does this thing cross the axis? What values of theta does this graph cross the axis? Who can show show me the zeros on this graph? Come on up here, Dominic.
That's Zach.
Did it again. Here.
Oh.
Nice. Zeros, zeros, zeros. Bam. Okay, good. Does everybody see where the zeros are? Now, if I ask you to name those zeros, it would be negative 180, 0, 180, 360, 540, 720, and I could go on and on, right? Next page. Next page. How does that sine function repeat? It keeps going up and down. How often does it go up and down? Every how many degrees? Remember, well, 180 just goes like that, right? 360, right? 360 goes up once, all the way down once, and then back up to 0 again. And then it starts all over again. Starts from 0, goes up to 1, down to 3, or down to negative 1, and back up to 0. Every 360. It repeats every 360. All right, now we're doing cosine. I want you to do cosine on your own. Fill in the table, do the graph. I'll give you 5 minutes and then we'll talk. 5 minutes. So, you never got a unit circle? You grade with Erickson, don't you? All right. So you'll want to see the value of cosine, right? The x or the y. Yeah. So what's the coordinate of that point? Yeah. No. Remember, this is 0, 0, right? But what's the radius of my unit circle? A line, let's just like one, so it's all a half. Right? So that makes this one what? X first. 1, 0. What's this one? 0, 1. There you go. Oh, yeah. Yeah, that looks like a 6 for a second. Yeah, I know. That's why I'm good at math. I'm always good at math. Now, as we go up, the sine, this is the sine value, right? This is the y value. That's where we got this first graph that we did on the first page. So, this is x, and this is y, but this is also cosine value. And this is the sine. All right? Notice your x values get smaller as you go up. Right? At least they do up until it gets smaller here too, right? It's just getting bigger in the negative direction. And they keep getting smaller until they're all the way over here in the negative. They start getting bigger. All the way over. Now we're going to go about those All right. Who got these for their numbers? All right. Does anybody notice anything? Oh, sorry, girls. Anybody notice anything fishy about these numbers? Danica, phone down, please. What is fishy about these numbers? What do you think, Jesse? What do you mean backwards? Tell me more. They're the same numbers as before, right? They're just kind of in a different order. On the first graph, or on the first table, they started at what? 0, right? Now they start at 1. So let's graph this and see how it changes. Again, just like before, we're going to start at 0. And when x is 0, when theta is 0, my function equals 1. So that's right here. And then when theta is 30 degrees, it goes down to 0.9, so right about there. 45 is 0.7, 60 is 0.5, and 90 is 0. And then we do the same thing, except in the negative direction. Now we're going 120 is negative 0.5. 135 is negative 0.7. 150 is negative 0.9. I feel like I'm talking to myself here. I'm feeling kind of disrespected right now. Thank you. And at 180 degrees, I'm back at negative 1. And then from 180 all the way up to 270, I go back to 0. The same way I did before, right? Boom. Boom. Oh, wrong place. Boom. No, that was the right place. What am I doing? Boom. Boom. And then lastly, I go boom, boom, boom. I don't like that. It's too far. And then boom. Now, if I do blue, if I do a skinny blue line, connect these dots, I do it better when I'm going this way. What does the rest of my graph look like? Do this out to 720. If I do this out to 720, what's it going to? It's going to do the same exact thing that it did between 0 and 360. So let's finish that. Let's go, and that would be at 450 would be 0, and 630. So we'll do that. And then, over here on the left-hand side, from 0 going back to 180, what's it going to do? It's going to go back down to what?
60.
Oh, wait. I screwed up there. It's going to do this. And if I compare this graph to the other graph, what do I notice? Is it the opposite? So in other words, this, when you say the opposite, here's what I see, Julia. Did I get it right? Oh, good. I thought it. When you say the opposite, I think that. Is that what you mean? No. There's something different going on. Remember, sine, I'm going to do this in green. Sine was this. All right. So look at this, kids. This is important. We did the cosine in blue, but I put the sine in green next to it. What can you say about cosine and sine, the relationship? Caleb. It's moved across. It's moved from left to right, right? I'm taking one and I'm shifting it. We call that a horizontal shift. Okay? That's why it's called cosine, because it's a cofunction of sine. Okay? I think Sarah asked that question yesterday. Maximum and minimums are going to be different. All right. So, assignment for tomorrow. On the back, you have an exit ticket. You get 2 graphs to do. Two graphs to do. Okay? Do tomorrow.